Hi Pre-Calc, this is the lesson on ellipses and it's broken down into two parts all in one video, but two parts. The first part we are graphing ellipses from the standard form and then also using completing the square to change an equation into standard form. So first of all, just kind of a reminder, a circle, that's what we did last time. A circle is a set of all points equidistant from one point in the plane, and that point is called the center. Now, the difference between a circle and an ellipse is an ellipse kind of has like two centers, not exactly centers, but they're actually called foci. So an ellipse is the set of all points whose sum of distances from 2 points is constant. And these 2 points, like I said, are called foci, or the singular word there is focus. So here's a good little demonstration, a good visual of what's going on here. So these 2 points, where the blue line and the red line are coming from, those are your foci. And you can see as the point moves around the circle, the length of the blue line changes, the length of the red line changes, but what stays the same is the sum of those two line segments, and in this case that total length always stays 10, and obviously it will change depending on the side of your ellipse, but yeah, the sum of the points, or the sum of the two distances remains the same around the edge of an ellipse. Okay, so just to kind of wrap our heads around this a little bit better here, the standard form of an ellipse is shown here. So it's quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1. So kind of some important things to pay attention to. That's always going to be a plus sign. That's always going to be 1. Now, a and b could kind of change places. So I always think of it as a is always going to be bigger than b. Okay. So sometimes your ellipse is going to be horizontal. That happens if your A is underneath your X term, or your ellipse could be vertical. So it could look like this if the B is under the Y value. And we're going to look at a bunch of examples, so I think we'll figure that out, but just to kind of start thinking about that. And then I think that a diagram there is a pretty good one. So we can figure some things out just from looking at that diagram. HK is the center of our ellipse, so same as it was with a circle. The distance from basically the center to the long edge is A. The distance from the center to the short edge is B. And then the distance from the center to one of the one of the foci, or the distance from the center to a focus is C. Okay. Then there's this other little equation that we'll use quite a bit. It's c squared equals a squared minus b squared. So remember there that a is going to be your big number and b is going to be your small number. And C, once again, is the distance from the center to a focus. So C is helpful for finding our foci. That's kind of what we use that for. Okay. Major axis, a couple of little vocabulary words down here. Major axis is your long axis. So if I was going to put that on the diagram, it would be this guy. That's your major axis. Your minor axis then is your short axis. So if I were putting that on the diagram, it would be this guy, your short axis. Your foci, we kind of already talked about that, but those are your 2 points here. There's one focus. There's the other focus. Center, I think that one's obvious. It's right in the middle of your ellipse. Vertices, you actually kind of have a major set of vertices and a minor set of vertices, and I'm just going to kind of put those on here. So these are your major vertices. And then these guys are your minor vertices. So you're going to end up having 4 vertices total, 2 major and 2 minor. And those are just going to kind of help you make your edge. So you'll end up with 4 total. Okay. Semi-major axis, that's half of your major. And then the semi-minor is obviously then half of your minor. So if you're kind of drawing that on here, like semi-minor would be that little blue segment I just made. Semi-major would be that distance. And that'll come up in some of our kind of word problems later on. So just good to kind of have an idea about that. Okay, standard form. So I talked about this a little bit. So A is always going to be bigger than B. So if your A falls underneath the X's, you are going to end up with like a horizontal ellipse, one that looks like that, okay? If your A is under your Y, you're going to end up with a vertical one. Now, it's not necessarily always going to be first like that. You could have your X's first and your Y's second. So what I mean by that, you could have like X minus H squared over B squared plus Y minus K squared over A squared. Okay, and in the problems, you're usually not going to have A and B. You're going to have numbers. So just look for wherever the bigger one is. If the bigger one is with the X, it's horizontal. If the bigger number is with the Y, it's going to be a vertical ellipse. Okay. This screenshot here is right from the textbook, and I found this to be really helpful. So I'm going to keep referring to this. This just kind of has all of our information on it. So this part here, we kind of already talked about the standard form. So you can see in that first example or first case, the bigger number, the A, is underneath the X, so it's a horizontal one. There's a nice picture that kind of gives us our major axis, minor axis, our foci, our center, all of that good stuff. And then over here, this is just a bunch of helpful information that we're going to keep using. So if we are dealing with a horizontal ellipse, center is going to be at HK, foci are going to be at H plus and minus C and K. So there's going to be two different points there, obviously H plus C and K, and then H minus C and K. Major axis, we don't really care too much about that one, but it'll always be at Y equals K. Major axis vertices are going to be at H plus and minus A and K. 2 points obviously there again. Minor axis at X equals H, and then I'll quit reading from there, you can read the rest. But then things change a little bit if we have a vertical ellipse. So if our bigger number is underneath, like right here, A is our bigger number. If A is underneath our Y, things change a little bit. The major things that change are how we calculate our foci, how we calculate our major axis vertices, and how we calculate our minor axis vertices. So it's going to change depending on whether we have a horizontal or a vertical ellipse. So let's just dive into an example. So we're going to graph this guy here. So x squared over 16 plus y squared over 9 equals 1. So what I do every single time I graph one of these is I just make the decision, is it a vertical one or is it a horizontal one? So to determine that, we're looking at these numbers, 16 and 9, okay? The bigger number, 16 is bigger, it's under the x. If the bigger number is under the x, it's going to be that kind. It's going to be a horizontal kind. So I will just kind of write that right on my paper so that I don't forget that I'm working with a horizontal one, okay? Then I always just reference this thing. So right from the textbook, I would have that written down on my paper or print it out so I have it right in front of me. And then I'll just kind of go through the important information that we need. So I always like to find the center first, just because it's easy and it kind of grounds us a little bit. So center is going to be located at HK. Actually, before I even do that, I'm going to make a list of the things I need. H, K, A, B, and C are all of the things that we need. So if you look over here, we have H, K, C, A, and B. So that's all the things we need. So H in this case, well, there isn't really anything. There's nothing next to the X up here. So it's just 0. Same with K. This is a pretty easy example. Nothing there. A is going to be, so remember in the general form, or in standard form, that bottom number is A squared. So to find A, we just take the square root of 16, which is going to be 4. And then for B, we take the square root of the smaller number. So square root of 9 equals 3. And then to figure out what C is, we got to do a little bit of scratch work there. We have to use this equation. C squared equals A squared minus B squared. So in our case, we don't know what C is yet. We do know A squared is 16. We already had that from the beginning. This is A squared, and this is B squared. So 16 minus 9, that's going to give us 7. So A is the square, sorry, C. C is the square root of 7. Okay, sorry, now we can go back to the center. So center is at HK, so in this case, 0, 0, and we can fill that in on the graph, okay? Next thing that I would probably do is find all of our vertices, and I like to split them up. I like to do my major vertices and then my minor vertices next. So major vertices, so we are just following this right here. So there's 2 of them. There's H plus A and K. So I'm going to write that down just for our notes. There's H plus A and K, and then there's H minus A and K. So for our case, H plus A is 0 plus 4, 0 plus 4, which is 4, and then K, which is 0. And then H minus A, so H is 0, 0 minus 4 is negative 4, and then K is 0. And then we can plot those, 4, 0, and negative 4, 0. Okay, then we can go to minor vertices. And our minor vertices happen at, if we follow this, H, and then K plus and minus B. So H, and one of them is K plus B. The other one is H and K minus B. So in our case, H is 0, K is also 0, B is 3. So 0 plus 3 is 3. And then over here we have 0, and then 0 minus 3 is negative 3. So 0, 3, and 0, negative 3. And that right there is actually enough to graph it. So we just kind of follow this around as smoothly as we possibly can. But a couple more things that we're going to talk about, just because this is the first one in our notes. We'll kind of just keep going with this. We're going to find the foci. So I'll just go down here, and we'll go ahead and graph those 2 when we're done with them. So foci are at H plus and minus C and K. So H plus C, K, and H minus C and K. So if we substitute some things in there, H plus C, so 0 plus root 7 is just root 7, and then K is 0, and then 0 minus C, so 0 minus root 7 is negative root 7, and 0. Okay, so now we're not going to be able to graph these perfectly, but if we were to find the square root of 7, it'd be about 2.6. So one of our foci, not focuses, a focus is at, what did I say, about 2.60. So right about here. And then the other one would be at about negative 2.60. So right about there. So those are our foci. And then a couple other things we could talk about. Length of the major axis. If we wanted to know how long is our major axis from here to here, that would be what? 8? Yeah, so just kind of, you could just count the boxes there. That length would be 8. And then the length of the minor, if we wanted to do that, that would be 6. So do this distance here. And that kind of stuff will just come up later, so I just want to talk about it real quickly so we can have everything in this first example. This length of our minor would be 6. And that's really pretty much it. There's not a whole lot more we can do there. All right, next example. This one is maybe just a little bit more challenging, not too bad though. So first thing that I would do is decide on this one. Is it a horizontal one or is it a vertical one? And in this case, we can see that our bigger number is with the y. If that's the case, you're going to be working with one of these guys, which means we're going to want to reference this information here, the vertical one, okay? So again, before we even do anything, let's do H, K, and then A, B, and C. That just makes everything easier if we have all of our stuff right in front of us. So H goes with your X. Remember, it's kind of the opposite of what you see with your X. So -4 in this case. K is +3. A is the square root of 25, which is 5. B is the square root of 9, which is 3. And then C, we have a little bit of work to do. So remember, C squared equals A squared minus B squared. So C squared equals 25 minus 9. C squared then would be 16. So C is 4. So that's kind of nice. We end up with nicer numbers there. Okay. Then we can find the center. Center is pretty simple. Center happens at HK, so in our case, -4, 3. Up next, I would do the major axis vertices, or just major vertices is fine. So those are going to be at H and then K plus or minus A. So H, K plus A, and then H, K minus A. So we can just substitute our stuff in there. So H is -4, and then K plus A. So 3 plus 5 is 8. And then -4 for H again, and then K minus A. So 3 minus 5 is -2. And we can plot all of that stuff. So center was at -4, 3. And then we have -4, 8. Move this out of the way. And then -4, -2. And that should look symmetrical. If it doesn't, you did something wrong, I think, on mine. Yeah, I was off by 1. I counted around 8. So 3, 4, 5, 6, 7, 8. There we go. Yeah, that looks better. Looks symmetrical now. Okay. Now we can keep going with minor vertices. And our minor vertices happen at H plus or minus B and K. So H plus B and K, and then H minus B and K. So if we follow our stuff, H plus B, so -4 plus 3 is -1, and then K is 3. And then H minus B, so -4 minus 3, -7, and 3. So -1, 3 would be right there. And then what was it, -7, 3? There. And yeah, it should always look nice and symmetrical and kind of oval-like. And then we can just connect those. I think most of the questions in your assignment are going to ask you to also find the foci, so let's do that really quick. So for a vertical looking one, your foci are going to be at H and then K plus or minus C. So K plus C and then H, K minus C. So H is -4. K plus C would be 3 plus 4, 7. And then H is -4. And K minus C, so 3 minus 4 is -1. So -4, 7 and -4, 1. So there. And, oh, sorry, -4, -1. And there. And my picture obviously is not perfectly perfect, but yeah, so everything should look nice and symmetrical. And if it doesn't, you did something wrong there. All right, so moving on, what if it's not in standard form? So those two weren't so bad. It was pretty easy to find H and K and A, B, and C because it was written nicely. So that's not always the case. Sometimes you're not in standard form, but you're in general form. And we talked about this with circles. So we're going to do something similar to what we did with circles. So if you're in this form where you have like ax squared plus cy squared plus dx plus ey plus f equals 0 or something similar to that, you are going to have to complete the square just like we did in circles. So I'm just gonna kind of fly through this because we've already done it, but you're gonna group your x's and y's together, factor out the leading coefficients of each of those groups, and then complete the square. So kind of take half of your coefficient in front of the x, take half of it and square it, add it to both sides, do the same thing with your y's. And then when you're done with that, you need to get your equation equal to 1 in this case. Okay, so all of our equations for ellipses are going to be equal to 1. So your last step here is going to be to divide everything by 36 or whatever is over on your right side there, so that you end up in the right kind of form here, standard form. Okay, so let's just go into an example here. So we're not even going to graph this. We're just going to get it into standard form. So we have 4x squared plus 9y squared minus 8x minus 54y plus 49 equals 0. Okay, so we need to get that x's together first. So we have 4x squared minus 8x. And then we need to get our y's together. So plus 9y squared minus 54y. And then right now I am also going to get our 49 to the other side. So equals -49. Okay, then we're going to factor out the leading coefficient. So we're going to take a 4 out of the first group. That's going to leave us with x squared minus 2x. And then I'm just going to leave my blank right here, right now. Okay, then I'm going to do that for the second group. Take out a 9. That's going to leave us with y squared minus 54 divided by 9 is 6. So 6y plus a blank equals -49. And then we're going to need 2 blanks over there. That's how I always set these up. Okay, now we're going to take half of this guy and square it and add it to both sides. So half of -2 is -1. Square it, -1 squared is 1, so add 1. Now be careful, we're not just adding 1 to both sides, because that 1 is being multiplied by a 4. So 4 times 1 is 4. We're actually adding 4 to both sides. And then same idea here, take half of -6, that's -3. Square it. -3 squared is 9. So we're putting a 9 there, but we're not adding 9 to the right side. We're adding 9 times 9, which is 81 to both sides. Okay? Then we can just kind of simplify this all up. So we are going to have 4. We're going to write this now as something squared, and that something is going to be x minus 1 squared plus 9. And then, so basically it's just It's just what that middle term divided by 2 is squared. So y minus 3 squared. And then on the right side, negative 49 plus 4 plus 81 is going to end up being 36. Okay, and then kind of our last step here is to get the right side equal to 1. Only one way to do that, and that is to divide everything by 36. So now we're going to have x minus 1 squared. 4/36 is the same as 1/9. So we don't really need the 1, but we definitely need the 9. And then 9/36 is the same as a fourth. So y minus 3 squared over 4 equals 1. Okay, and then from there on your assignment, you are going to have to also graph these. But same exact process. You would just list your H and your K and your A and your B and your C. I'm not going to do the whole thing, but get all of those things listed. Make the decision, is this going to be a horizontal ellipse or a vertical ellipse? We'll check, find the bigger number, bigger denominator. It's a 9, and it's with the X, so it's going to be a horizontal ellipse. So you'll want to use the formulas that go with the horizontal one. All right, we'll do one more of those. I'll go through this one pretty quickly. You can, if you know how to complete the square, you could maybe fast forward through this one, but one more in case anybody needs it. So once again, we'll group our stuff together, group our x's together, and then group our y's together, and then subtract 64 from both sides to get that guy over there. Then factor out a 6, so take 6 out of both terms. That will leave us with 4x, add a blank. Factor out 4, that'll leave us with y squared minus 8y, and then leave a blank. And then 2 blanks on that side. Now take half of the middle term and square it. So half of 4 is 2. 2 squared is 4. Don't add 4 to the other side, though. Add 24. And then take half of negative 8, which is negative 4. Negative 4 squared is 16. Don't add 16, though. Add 4 times 16, which is 64. Okay. Then you're going to leave your 6 on the outside. We're going to make this trinomial into something squared, and it's going to be x plus 2 squared. We're going to leave our 4 on the outside, and we're going to do y minus 4 squared. And then on the right side, good news there, negative 64 and negative 64 is 0, so the adding is pretty simple. It's just 24. Last step, divide everything by 24, because we need our right side to be 1. 6/24, that's the same as 1/4. So x plus 2 squared over 4. 4/24 is the same as 1/6. So y minus 4 squared over 6 equals 1. And then you don't have to do any more right now, but just a little reminder here. Since the bigger denominator is with the y, you are going to have a vertical ellipse for that one. All right, moving on to part 2. In part 2, we are kind of just working backwards. So instead of graphing, we're either using a graph or other information to work backwards and write the equation. So just a little reminder, this is already in your notes. You don't need to write it down again, but this information here will be really helpful. So just remembering that HK is in the center. A is the distance from the center to basically the long edge. B is the distance from the center to the short edge, and then C is the distance from the center to a focus. So we're gonna use that information. We're also going to use that little clip from the textbook to help us through this stuff. So example 5, it says write the equation of an ellipse in standard form, then find the coordinates of its foci. So yeah, we'll go ahead and do all of that. So I guess where I would start is if you're given a graph here, let's find the center. So basically, if we're at -4 and -8 for x values, we kind of just need to find the middle of that. So you can add them together, divide by 2. So 8 minus 4 is 4. 4 divided by 2 is 2. So we're going to be right there. And then I think that's pretty obvious that we're at 2. So the center is at 2, negative 4. Okay, that tells us important information. That tells us what H and K are. So I would just go ahead and, like we were doing before, write those things down. H is 2, K is negative 4, and then let's see if we can find A, B, and C. Or at least find A and B. So A, remember from that picture on the last slide, A is just the distance from the center to a long edge. So 1, 2, 3, 4, 5, 6. A is 6. Pretty simple. B is the distance from the center to a short edge. And you can go either direction. 1, 2, 3, 4. Okay. And then C has to do with the focus, but we can use that little equation here. So remember we have that C squared equals A squared minus B squared. We can do that right now to figure out what C is. We have enough information. So 6 squared is 36, and 4 squared is 16. So C squared is 20. So C is the square root of 20. And we could reduce radical form that one. I think there's a 4 in there, so you could write it as 2 square roots of 5. But we'll just leave it as a square root of 20 for now. That's fine. All right, so now for writing the equation, we're good. We really have everything we need already. So it is a horizontal one, so our x's should come first. So it's just x minus h, so x minus 2 squared over a squared. So 6 squared is 36. And then you're always going to have a plus sign in the middle, and then you're doing your y's. So y minus negative 4. Y plus 4 squared over b squared. B squared, 4 squared is 16. And then we're always going to be equal to 1. So that's really it. That's your equation. They did also want us to find the location of the foci. So let's do that really quick. And I definitely don't always remember all of these formulas, so I will reference this quite a bit. So foci for a horizontal ellipse is h plus or minus c and k. And we can just write it as one ordered pair with the plus or minus in there. I usually don't, but I will in this case just because we don't actually really need to graph it. They're just asking for it. So h is 2 plus or minus the square root of 20. That's what our c is. And then k is negative 4. So that's where our foci would be located. So we could graph them, but it didn't ask us to, so that's fine. All right, example 6. So this time we're just given some information. So it says write the equation of the ellipse that has foci at 0, 0 and 0, 8 and has a major axis length of 16. So I would definitely use the graph to kind of give us a visual of what this might end up looking like. So let's plot these foci. We have one of them at 0, 0 and one of them at 0, 8. Right there. So 0, 8, and 0, 0. Now, before I even keep going, I'm going to add the center. The center is always going to be exactly halfway between your foci. So our center is going to be at 0, 4. And that's important information because that's going to give us our h and our k. So actually, I'm going to write that down right away. H is 0 and k is 4. Okay, then we can keep going. It says that our major axis has a length of 16. So that means from the very bottom of our ellipse to the very top of our ellipse is going to have a distance of 16. Now that's going to be a little bit tricky, and it's actually going to end up going off of our graph. So what I'm going to do is I'm just going to cut that in half. So I'm basically going to find the semi-major. Can't write. So semi-major is going to have a length of 16 divided by 2, which is 8. So then what I can do is I can just start at the center and count. I'm going to go down because I know that one won't fly off the graph. Count down 8 from there. 1, 2, 3, 4, 5, 6, 7, 8. Right there. So that is going to be the edge of our ellipse. So that distance is 8. And then we could keep going up, but like I said, we're going to end up kind of flying off the graph here. That distance is also going to be 8. Now, we already know what kind of ellipse we have. Because our foci are in a vertical direction, our major axis, we already know is vertical. We already know that our ellipse is going to look like that. So at this point, basically the question is just like, how wide is this thing, or how narrow is it? Basically, we need to figure out what our B value is. Okay, so let's fill in some more things that we know. We do know what A is. A is this distance right here from the center to one of the edges. So A is 8. Okay, B, we don't know yet. That's our minor axis, or has to do with our minor axis. We don't know what that is yet. We do, believe it or not, know what C is. C is the distance from the center to a focus. So we have a center, we have a focus. The distance there is 4, and that's our C value. So that's kind of the trick to this problem, I think, is just kind of realizing what all these different missing pieces of information are in order to find them. So we actually do have A and C. We don't have B yet, but we can do a little algebra to figure it out. We can use our C squared equals A squared minus B squared, substitute our stuff in. So 4 squared equals, we have A squared is 8 squared minus our unknown B squared. So 16, 64, subtract 64 from both sides, and we get negative 48 is negative B squared. Just multiply them both by -1, divide them both by -1, make them both positive, whatever you want to do there. And then we can take the square roots of both sides. So B is equal to the square root of 48. All right, and like I said, we already know that we have a vertical ellipse. If we wanted to, we could figure out what the square root of 48 is. Let's see, it's close to 7, 6.9. So if we really wanted to add that to the graph, we certainly could. We could go over 6.9, and we could go left 6.9. And we could finish drawing our ellipse, but we're going to end up going like way off the graph anyway. But if it helps to visualize that, definitely go for it. But I think at that point we are ready to write our equation. So since it's a vertical one, we probably want to do our y's first, although it doesn't really matter. The order you do it doesn't really matter, as long as the 64, the A squared, goes with your y's. Okay, so it's y minus k, so y minus 4 squared. Make sure that goes with 64, plus x plus 0, or just x squared, over square root of 48 squared is 48 equals 1. So that's fine. I think that's the way that it's going to look on the answer key. You are not wrong if you do it this way. That's a totally acceptable way to write your answer as well, as long as the 64, like I said, is underneath the y's. All right, and then one more example here. This one is probably the trickiest one, but not so bad. It says, write the equation of the ellipse where the length of the semi-major axis is 3/2, so basically 1.5 times the length of the vertical semi-minor axis. The center is at 2, -4, and A equals 6. Okay, so to just wrap our heads around this a little bit, let's start by putting the center on our graph. So, right, oops, 2, -4 over here. All right, so we have that. It says that A equals 6. Well, I don't know right away if that means we should go up 6 or if we should go to the right 6. until we kind of go back and read the problem. So it says the length of the semi-major axis is 1.5 times the length of the vertical semi-minor. So that means that the minor axis is vertical, okay, which means that the major is bigger, if you can wrap your head around that. So that means that the horizontal is longer, and it's 3.5 times longer, okay? So what I would do next is I would do this A is 6, okay? So if A is 6, that's going to put us over here at 8. Okay, maybe move this. Okay, so this distance is 6, which means we are at 8, -4. And then we could also go in the other direction. We can go back 6, which is going to put us at -4, -4. Like that. Okay. And then it says that this semi-major axis is 3.5 times the length of the vertical. So what that means, it means that we need to multiply the minor, we need to multiply the B by 1.5 or by 3/2 in order for it to be equal to the major, to be equal to 6. Okay, so to figure out what that's going to be, we would just multiply by the reciprocal. And then that's going to tell us that, let's see, 6 times 2 is 12. 12 divided by 3 is 4. So B is going to be 4. So it always takes a little bit to kind of picture in your head there what that's saying. But if you think about it, your B needs to be multiplied by something bigger in order for it to end up being that bigger number. So B is 4. So let me just go ahead and write down our information again. So H is 2, K is -4, A is 6, B is 4, and C, I don't even think that we really care about C in this case. I don't think we even need to find it. So we can just go ahead and write our equation. Since it is a horizontal one, our what do we have here? We have the major axis is horizontal, so we know our axis should come first. So x minus 2 squared over a squared, 6 squared is 36, plus y minus -4, so y plus 4 squared over b squared. 4 times 4 is 16, and that should be equal to 1. So there is one like that in the practice. Definitely make sure to check that one out. Sorry, my graph isn't very straight there. It's hard to see. All right, sorry for the long video. That was a lot. Good luck.